Hello and welcome back to today's lesson. Today you are going to learn about future selection techniques in machine learning. In this tutorial, you will learn how to select the best relevant futures from number of futures in machine learning. The goal of future selection techniques in machine learning is to find out the best set of futures that allows one to build optimized models of studied phenomena. Here are the reasons why future selection is crucial in machine learning. One is preventing overfitting. Future selection helps prevent overfitting by focusing on the most relevant futures, reducing noise, and improving the model's ability to generalize to new data. The second is enhancing model performance. By selecting the most informative futures, future selection leads to improved model performance, including higher accuracy and faster computation. We also use future selection techniques in simplifying model complexity. Future selection simplifies models by eliminating irrelevant or redundant futures, making them easier to interpret and understand. The other reason is why future selection is crucial in machine learning: efficient computation. Working with a reduced set of futures speeds up the training and inference process, making the overall learning process more efficient and scalable. So in this tutorial, I have selected a dataset, which is a breast cancer dataset. It is a well-known and easy accessible dataset, often used for testing purposes in machine learning. It is also included in the scikit-learn library and contains a small set of data to demonstrate various machine learning techniques. So to implement these future selection techniques, I'm going to import necessary libraries in the cancer dataset from scikit-learn module. So here, load breast cancer class is imported from scikit-learn because this dataset is included in the scikit-learn library for testing purposes. So everyone can use this dataset to learn by implementing different techniques of machine learning models. And also import select k-based class from future selection module in the scikit-learn library, and chi-square. Chi-square is the most important method to select the top ranked futures in our machine learning. Finally, we're going to visualize the top ranked futures in the bar plots to understand which is relevant and which is not relevant according to the chi-square scores. Okay, once we import necessary libraries in the cancer dataset, we are going to load the dataset and separate the X metrics or X futures and the target variable. Here are the X futures. I just converted to the data frame. That is easy, and the target is already attributed as target variable. So let me explore the futures in the X variable. All the futures are here. So we have 30 columns. Columns means future variables that represent the columns. And in this dataset, we have 569 rows. So we're going to select the most relevant futures from this dataset. To perform future selection using chi-square, actually you can use different methods to select the best or the most relevant futures, but it is depending on the behavior of the dataset you have. If you have a categorical futures. It is recommended to use chi-square to select the best futures. So the chi-square is used for categorical futures in a data set. We calculate chi-square between each variable or future and the target variable. So it just calculates the scores between the categorical futures or each futures and the target variable. So what are the relationship between the variables or futures in the target variable? So it's going to calculate the scores, and in order to correctly apply the chi-squared to test the relationship between various features in the dataset and the target variable. Finally, it's going to select the frequency which is greater than 5. So the top ranked futures can be selected based on the frequency of the chi-squared and desired relationship between the futures and the target variable according to the scores of the chi-square. Okay, let's implement this. So we have to declare the classes, select k-based, and we pass the chi-square. It's going to calculate the frequencies of each futures and the target variable. And here, it's going to select the top 5 futures according to the chi-square, which is greater than 5. And then we transform the values into the x and y into this fit and transform. And then selected futures is according to the chi-squared and converted into list. Here it's going to just converted, select the top ranked futures and converted into lists. And we can see that top 5 futures can be listed out here. So mean perimeter, mean area, area errors, worst perimeter. These are the top 5 most relevant futures which are selected from 30 columns. Okay. Then we're going to plot the result and select the top ranked. Here, let's run this and let's see the visualization of the classes. So in the Y, the scores, the chi-square scores, and the x-axis represents the futures. This bar plot shows that the scores which is in each future. We can know that we can understand by looking at the scores of each future. So these are the top 5 futures which are selected with chi-square scores. The others, if you change this to 10, so we can see, we can compare each futures and let's see the output. Look at this. Here, for example, mean radius has 0 scores. So this is the least relevant. So it's not important to select this future. We just exclude while selecting our futures. So we are going to select top ranked futures from the data set. So this is, I hope this tutorial is useful. And in essence, future selection is essential for building more accurate, interpretable, and efficient machine learning models. Don't forget to like, share, and subscribe. Write your comment in the comment section of this video. Thanks for watching.